VLSos here. This is a video lesson on inverse of a power. For example, we've talked about solving equations. If we have an equation that includes a power like x to the power of 2, or we could say x squared is equal to 9, the solution process means that we want to undo what we see in order to get the variable alone and positive on one side. If we see that we are raising x to the second power, then we might wonder what's the inverse of that power of 2 that will cancel it out, leaving x. The inverse of powering what will undo a power, an exponent, is rooting. We'd say a root undoes an exponent. So in this equation here, we have x squared is equal to 9. What we need to do to both sides to undo that square is the square root. It looks like this. We use the radical symbol to show our work. And if there's no number in this part of the radical symbol, then it's the square root. The square root will cancel the square, leaving x by itself, because they're inverses. On the other side, we want to find the square root of 9, or a number when multiplied by itself is equal to 9. Calculator can help us out. We might be familiar that the square root of 9 is 3. We've solved for x, and we've found the solution to the original equation 3. Let's have another example. X to the power of 3 is equal to 28. Or we could say x cubed is equal to x cubed plus 1 is equal to 28. We want to solve for x. We want to get x by itself, alone and positive on one side of the equation. We do that by undoing operations, by doing the inverse of what we see to both sides. The inverse of addition is subtraction. I'm going to subtract 1 from both sides. When we do, these cancel out, leaving x cubed is equal to 28 minus 1 is 27. I need to undo the power of 3. The root will undo this power of 3, but I'm not going to do the square root to both sides. I need to do the cube root. So I'm going to root x cubed with the cube root. I'm also going to take the cube root of the other side, 27. The cube root will undo the cube, leaving x by itself. And the cube root of 27, I need to evaluate. You could use a calculator. What I'm looking for is a number times itself again equals 27. That's 3. 3 times 3 is 9, times 3 again is 27. X has been solved for. 3 is the solution to the original equation. With the inclusion of the inverse of a power, we can now list the inverse operations that we're familiar with. This helps in the solution process solving for a variable. We undo addition with subtraction. And we undo subtraction with addition. Addition and subtraction are inverses. We undo multiplication with division. and we undo division with multiplication because they're inverses. Now we're thinking about undoing an exponent in a power, like x to the n exponent, with the inverse nth root. And we can undo the nth root by the nth power. Powering and rooting are inverses.